Okay. Can someone confirm if my voice is audible and the screen is visible? Please check your audio and video settings. Are you able to see? Okay, okay, Revati. So yesterday we were discussing. Okay, Prasanna. Yes, okay. So yesterday, let us do a quick recap. Today we were discussing about what? We were discussing about number systems in Java. So we have understood. We have no doubts about decimal number system, and we have also completed the binary number system. So decimal means always the base is going to be 10, and we have understood yesterday why it is 10. So we have got that understanding, and for the binary number system, the base is always going to be 2. Right, the base is always going to be 2, and we have seen some things. Okay, literally we have seen some things like whatever the data that we send, that is going to be stored in the form of zeros and ones, because the any electronic machine, they can understand only zeros and ones, right? After that we have also discussed about the smallest memory unit, which is what? A bit. Okay? A bit is going to be what? It is the smallest memory unit in the machines, in the electronic machines, right? And also we have discussed the combination of 8 bits is going to be what? It is going to make 1 byte, right? And we have discussed something about a transistor, how does the transistor looks, and why the binary number system, why the binary system has come into the picture. We have had that discussion as well. And after that we have discussed something about what? We have understood how the calculations are happening when you pass 10 plus 20. So arithmetic calculations, for doing any arithmetic calculation, we human beings, we use decimal number system, but the computers, they follow the binary number system. Okay, so after this we have also discussed about okay, we have just started about the primitive data types, right? So I have given you the sizes, right? So there are totally 8 primitive data types. So when you say byte, it's going to consume 1 byte of memory. For the short, 2 bytes, and so on, right? And today we will understand about the range calculation, right? From which range to which range, you can store of which numbers is qualified enough to get stored under the byte data type, which are the numbers that is qualified enough to store under the short data type. So that we will understand today, right? And that's it. Now let us see. Good evening, Lakshmi. Okay, so first we will understand about the first 4 data types. Okay, what are the data types that we have? Byte, and I said byte is going to consume 1 byte of memory, and followed by we have the short data type, which is going to consume 2 bytes of memory, followed by you have int data type, which is going to consume 3 bytes of memory, and at last we have what? We have something like long data type, which is going to consume how many bytes of memory? 4 bytes of memory, isn't it? No, I'm wrong. I thought you people will correct me. So int is going to consume 4 bytes of memory, long is going to consume 8 bytes of memory. Okay. 8 bytes of memory. Okay. These are the ranges. So the Java people has given some ranges for these data types, right? So I mean the size they have given. So range we are going to discuss today. So when I say 1 byte, they have come to a formula. They have given a formula. The formula says, let me take my pen. Okay, to calculate the range. Okay, they have given a formula. The formula says minus 2 to the power of n minus 1. Okay, so this is the range for negative numbers. Okay, the range for the negative number, it is going to start from minus 2 to the power of n minus 1 to, okay, positive 2 to the power of n minus 1 minus 1. Okay, what does it really mean? Here the n is representing what? Number of bits. Okay, n is representing what? Number of bits. Okay, and we know that byte is consuming what? Byte is byte data type. When I say byte data type, we know that the byte data type is consuming 1 byte of memory. Okay, to make this formula, okay, to substitute this formula, we need to understand how many bits of memory that the byte data type is consuming. So 1 byte is equal to how many bits? You need to just multiply with 8, right? So that you will get number of bits. So 1 byte is going to be what? 1 into 8. It is going to give you how many bits of memory that the particular byte data type is consuming. So you will end up in getting 8 bits of memory. You will substitute this 8 in place of n. In place of n, you will substitute this 8. Let us do the quick substitution. Minus 2 to the power of, okay, minus 2 to the power of what? 2 to the power of 8 minus 1, 2. Okay, positive 2 to the power of 8 minus 1, okay, minus 1. Okay, after the substitution, you get what? 2 to the power of 7 to 2 to the power of positive 2 to the power of 7 minus 1. After the complete substitution, okay, 2 to the power of 7 is what? Anyone can help me with the answer? Anyone? What is 2 to the power of 7? Anyone? Mathematics, guys. What is 2 to the power of 7? Hello, am I audible? What value you will get for 2 to the power of 7? Sudhir, Revati, Prasanna, Lakshmi, Purnima.
128.
128. Yeah. Okay, now you're going to get minus 128 to, again, okay, 2 to the power of is 128 minus 1, okay, 127. Okay, this is the range value for the byte data type. If I ask you how many, what kind of values that the byte data type can store, you should say minus 128 to positive 127. You can store the numbers between these two ranges. From negative to positive, only these ranges are applicable for the byte data type. Right? And also when you want to find the same thing for the short data type, you will use the formula. You will use the same formula. Apart from that, you will not do anything. You will try to find number of bits. After finding the number of bits, you will try to find, even you will get the actual range. Very easy, right? You do not have to memorize this. You do not have to memorize this. You can just memorize this formula. I will help you how they have arrived to that formula. Okay. Now let us do some see. Now, for example, in the real-time applications, right? What will happen is, so there will be a front-end team, guys. Okay, focus here. There will be a front-end team, okay, and there will be a back-end. So we come under back-end team. Okay, since we are developing Java, we come under back-end team, and you can take any team. Like front-end can be like JavaScript, Angular or React, whatever it is. Let us say that front-end team is working on top of JavaScript. Okay, JavaScript. So there is let us understand that there is a requirement. The requirement says there is a form. Okay, so you open a website. Okay, for example, let us say that www.java.com or www.java.com. You open this website and it is giving you a form. The form says the form has many fields. So there are many fields. Like if you open that form, you are finding many number of fields. But one of the field says, please enter your experience. There is a tile is asking you to what? Enter your experience. EXP. Okay, when it experience in years. Okay, when it comes to experience, don't you think that whatever the number that they are going to enter, naturally the experience will not cross, or sometimes the biggest experience that you can consider is maximum 100 years of experience. Maximum at any cost. If you consider all the odds, you can say I have 100 years of experience in Java as a Java backend developer. When you say that, your age must be around 128 or 120, something like that. But to store this value, the possible values can be from what? From can be 0 to 100, maximum 100. At the worst case, it can be 100. If you have any such cases, not only experience, if you have something like year, okay, how old are you? What could be the possible answer? Maximum he can enter 100 in that field, right? Maximum at any cost he can enter 100. Right? If you have things like, if you think that the data will be less than 100 or data will be less than 127, it cannot exceed more than that. So these are the 100% guaranteed things, guaranteed example, guaranteed tiles that the front end can make. Let us consider this experience only. They have designed a template, and the end user needs to enter something. End user needs to enter something at any cost. He cannot enter more than 100. Okay, you backend developer, we as a backend developer, we need to catch this value to perform some manipulations or to send it to the database. Whatever it is, we need to catch this value. To catch this value, don't you think that possibly I can go for byte data type, because the byte data type is just consuming 1 byte of memory. Even I can choose short data type, no issues. To catch this, I can use short data type. I can say short experience equal to, I can catch that value, no issues. Even I can choose int data type, no issues. What is the best way? What is the feasible way that I can choose? I can go for byte so that I can save more memory. If I go for int, is accepted. But the problem is, to store the small value, why we have to choose the int data type? It is consuming about 4 bytes of memory. The remaining memory is a wastage, isn't it? I can directly go for byte data type. Right? In the real-time application, there will be such cases where you want to cache the data from the end user, and you have to assign it to a particular data type. Depending upon the value, that you should come to a conclusion that, okay, this byte data type is going to be very much feasible, because the experience cannot be more than 100 years. Even at the max, at the worst case, it can be 100, or it can be 101, whatever it is, but it cannot be 127. It cannot be more than 127. If it is 127 also, no problem, because byte is capable to store 127 as well, but it cannot be more than that. Yes or no? In such cases, you should be in a position, you as a backend developer, you should be in a position to choose what kind of data type would be accepted, what kind of data type would be feasible. Like in this case, you will go for, so this is how you this is how, by based upon the value, you have arrived to a conclusion. Okay, byte can store 120 to 127. What are the possibilities? Okay, in what kind of situation that we can choose this byte data type? So this is one of the example. Now the question. Now I am asking. Now the question session. I am saying. Now you tell me this is valid or invalid. So class A. Okay. Now I am saying byte B equal to 135. Now tell me valid or invalid. Everyone. Invalid. Why invalid? If you see, if you see the value, the value is crossing the range. It is not between 128 to 127. It is above that. In this case, it is, you cannot store a value that is out of the range. You cannot store a value that is out of the range. So what is the valid? Okay, now tell me byte A equal to something like minus 126. Valid or invalid?
Valid.
Completely valid, because it is within the range. Okay. So now we will say, sir, you are telling everything is fine. How they have arrived to that formula? You have said a formula. You are saying that the formula is minus 2 to the power of what? Minus 2 to the power of n. N is representing number of bits, right? N minus 1, 2, okay, plus 2 to the power of n minus 1 minus 1. Right? So this is the formula that they have said. How they have arrived, how they have concluded that this is the formula, that we will understand now. Then understanding remaining things are going to be dead easy. Okay, let us say that we are about how many members totally? We are 6 members. I mean, we are only 5 members today, including me, 6 members. Let us say that we are designing a programming language. In that programming language, just an assumption, okay, just follow me. Just an assumption, we are asked to design a programming language, and in that programming language, they are asking us to design our own data type. Focus here, own data type. So they are saying that data type needs to store only 4 bits of memory. The capacity of the data type has to be what? Only 4 bits of memory. So this is the what? This is the requirement. This is the acceptance criteria. 4 bits of memory. And also they are saying that, okay, and you can give whatever name you want, but it cannot consume more than 4 bits. It should be approximately 4 bits of memory should consume. And they are asking you to name, you can name whatever you want. So I want to name our own data type, like, so we have byte. So let us take it as kite. Okay. I can also conclude that since it is going to consume only 4 bits of memory, I can also conclude that it consumes half byte of memory. So no, consumes half byte of memory. Okay, so 8 bits is making 1 byte, guys. So when I say 4 bits, it is going to make how many byte? Half byte, isn't it? Okay, we have started designing in the real-time application. So this is how you can understand when I say half byte. Okay, half byte means 4 bits. So this is bit 1, bit 2, bit 3, bit 4. 4 bits. 1, 2, 3, 4. There are 4 spaces now. So we can call it as, okay. So we have a memory space of how many bits? 4 bits. Okay, 4 bits. If I ask you the possible combinations, okay, how many possible combinations would be? Okay, let us do this really quick. If I talk about the possible combinations, there will be 16 possible combinations. I will tell you why 16. Okay, 4. Okay, 8. Focus here, guys. This is very, very important. No one will teach you the internal things. Okay, and 16. There will be 15 possible combinations. How I am saying it is going to be, 16 possible combinations. 16. I am saying 16. Okay, how I am saying that there is going to be 16 possible combinations. Just understand, okay? I can fill 0. When I want to fill 0 as a decimal number, if it gets converted to binary, everything has to be 0, right? Okay, 1 as a decimal, but 1 in binary is what? 0, 0, 0, 1. Okay, 2, 3, 4. So 2 in binary is what? 1, 0, right? And 3 in binary is what? 3 in decimal. I am just converting it to binary and filling the places. Okay, 3 is what? 111, 0, 0. Okay, and again 4 is what, guys? 1, 0, 0, 1. 1, 0, 0. 1, 0, 0. Sorry, this one is 0, guys. 1, 0, 0. This is representing 4. 5 is what? 1, 0, 1 is 5. Remaining the space that is empty has to be filled with 0. Okay, and 6 is what? 1, 1, 0. Correct me if I am wrong. The 7 is what? 1, 1, 1, 0. Correct only, no, Sudhir?
Yes, sir.
6, 7. Okay, and 8 is what? 1, 0, 0, 0. Am I correct? Right? And 9 is what?
Yes.
1, 0, 0, 1. Okay. And the 10 is what? 1, 0, 1, 0. 11 is 1, 0, 1, 1. Right? And 12 is 1, 1, 0, 0. 13 is 1, 1, 0, 1. 14 is 1, 1, 1, 0. Right? And the 15 is what? 1, 1, 1, 1. Okay, if you see,
Okay.
we have how many bits of memory? We are designing a data type which is of 4 bits. Right? For 4 bits, if you see, I am able to store how many values. If I ask you the range, what is the range of your data type? If I ask you, okay, if our team leader is asking me, okay, you have designed it very perfectly, what is the range of the data type? Can I say my data type is holding numbers from 0 to 15? Okay, including 0, it is going to store 16 values. Can I come to this conclusion? But there is a problem here. There is a problem. We are able to store only the positive numbers. But I want to make a way to store the negative numbers as well. I also want to make a way to store the negative number. If you look at this, so 0 to 15, okay, I am able to fill all the spaces, but everything is positive number. I should also want to store the negative number. What is the possibility? What is the possibility? So there is a beautiful concept. There is a beautiful concept called MSB. What did I say? There is a beautiful concept called MSB. Focus here. Focus here. MSB. MSB stands for most significant bit. Anyone know about this? Anyone? From this class, Sudhir, Prasanna, Revati.
No, sir.
You are hearing this for the first time. Okay then. See, most significant bits. Just try to understand. You have 4 bits, okay? The first space, okay, this part, this first space, the most leftmost bit, extreme left bit, okay, they call this area, they usually call this area, they reserved this area for MSB. they reserved this area for what? MSB. MSB is what? MSB standing for most significant bit. What is that most significant bit? That understanding we'll try to find. Okay. Now if you see the last bit, when I say most significant bit, try to go to the extreme left, and the extreme leftmost bit is called as most significant. Okay, and if you see, there are only two possible values. Okay, and let me start from the beginning. From here to here, from here to here, the value of most significant bit is 0. I can separate that. I just want to separate that. Okay, and from here to here, okay, from 8 to 15, okay, the value of the most significant bit is 1. Okay, now I am asking you guys, what is the value of the most significant bit for the number 10? What is your answer?
1.
What is the value of the most significant bit for the number 5?
0.
Now we have understood what is most significant bit. That's right. Now by this we will understand. We can say that. See guys. Okay. So they are saying, they are asking us to consider, okay, if the most significant bits are 0, okay, if 0 is landing on the most significant bit spaces, they are asking you to consider these places is reserved for what? Positive numbers. Okay, and if the number one, okay, is getting landed on the most significant bit space, they are asking us to treat them as what? Negative numbers. Okay, and again they are saying to treat the most significant bit as a negative number, they are asking you to do 2's complement. I will tell you what is 2's complement. Example. This is completely fine. Because then all the numbers 0, 1, 2, 3, 4, 5, 6, 7 till 7. By this, you can conclude that all these numbers are positive numbers. But this is bit confusing. Because if you consider it as a negative number, it will end up like -8, -9, -10, -11, something like that. Right? It should not be like that. So to avoid that confusion, they are asking us to do what? 2's complement. Now the question is, what is 2's complement? Okay, let us take this example. Focus here. I will keep it very simple. Let us take the number 8. Okay, what is the binary equivalent of number 8? Okay, 1 0 0 0. Okay, this is the binary number. Okay, to find 2's complement, okay, we are supposed to find first 1's complement. Okay, let me write it like this. To find 2's complement, first of all, we have to supposed to find 1's complement. C is representing complement. Very simple. 1's complement is what? This is the given binary number, right? Just flip the numbers. If you have 0, take it 1. If you have 0, flip it to 1. 0, flip it to 1. 1, flip it to 0. So this is 1's complement. Now you tell me, what is the 1's complement of 111? Come on. 000. Isn't it? Now what is the 1's complement of 101? 010. Now you are good at finding 1's complement. Then to find 2's complement, just add 1 upon 1's complement. Just add 1. Just add another 1. Okay. What is the number that you are going to get? If you add 1 plus 1 is going to be 10. 0 carry 1. 1 plus 1 is going to be 10. 0 carry 1. Again 1 plus 1 is going to get 0 carry 1. And again we are getting. So in this case, it's a coincidence that we are getting the same number. Forgot about this. So this is the 2's complement. We will go with another example. This is a coincidence that we are getting the same number. No worries. So this is a 2's complement. Now what you have to do? You have to raise the significance of 2's complement. I mean, we have to use what? You have to convert it to equivalent decimal number by choosing what? How do you convert it? By using 2 to the power of 0, you will raise the significance of powers. 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Very simple. You are starting it from here. Okay? You are raising the powers to 0 to convert it to the equivalent decimal. Okay? You will get some value. You will get what? You will get some value. Okay, so you will not consider these three things. Okay? these three numbers you will not consider because they are what? They are 0. Whatever you do, you will get 0. Whatever you do, you will get 0. So you will not take this 3. You will consider this. Okay, 2 to the power of is going to give what? Is going to give 8. Yes or no? Okay. Since it is a 2's complement, just add a negative number. Okay. Now if you see, instead of positive 8, you will get what? You will get the equivalent negative 8. Let us see one more example. Now we will take this number 9. Now focus here. Once again, I am repeating this. Once again, now we have something like 1, 0, 0, 1. So this is the equivalent binary number for the decimal number 9. Now tell me, what is the first? To find the 2's complement, you have to find the 1's complement. What is the 1's complement for this? Can you help me with that? 1's complement.
0, 1, 1, 0.
Yes, good. 0, 1, 1, 0. To find the 2's complement, we are supposed to add a 1 upon 1's complement. You are just adding a 1. What is the number that you are going to get? 0, 1, 1, 1. Yes or no? Okay. After getting this number, convert this to the decimal number. This is the binary number, right? You want to convert it to the equivalent decimal number. Okay, you will just raise the power of 2 with 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Okay. You will ignore this thing because anyhow it is going to give you 0. You have to evaluate these 3 powers, and typically the answer is going to be what? 2 to the power of 2 is 4, 2 to the power of 1 is what? 2, and 2 to the power of 0 is what? 1. So you will get what? 7. Since it is a 2's complement, you will add minus. Making sense? Now this 8, okay? This 9 becomes what? Minus 7. If you keep doing this, don't you think that this becomes minus 6? The pattern is created. This becomes minus 5. This becomes minus 4. This becomes minus 3. Okay? This becomes minus 2. This becomes minus 1. Have you understood so far? Yes, no? Unmute and speak.
Yes.
A pattern has been
Yes.
created, no? If you observe the least number that you can save is minus 8. Highest number that you can save is positive 7. I can conclude that our data type, the name of our data type is what? Kite. Our name of our data type is kite. Our kite data type is going to store numbers ranging from minus 8 to positive 7. Okay, now there is a pattern created. Okay, you are using 4 bits of memory. For 4 bits, what are the possible combinations? You can just do what? 2 to the power of 4. 2 to the power of 4 is going to give what? 2 to the power of 4 is going to give what? 16, right? 16. Right? This 4 is representing bits, right? See, 4 is representing bit. If you see, there are 16 combinations from minus 8 to positive 7. There are 16 possible combinations. Yes or no? Right? So by using this, they have raised the power to 2 to the power of n. Okay, if you some 2 to the power of number of bits. Okay, with our formula, I can conclude that I can make a pattern that, okay, we are getting minus 8, right? So this 2 to the power of minus 2 to the power of n. 2 over here we are getting positive 7. Positive 7 is, it is 1 less than 8. So 2 to the power of n minus 1. This is the pattern. For even if you want, you can try it for two bits. You can keep this data type as something like site, whatever it is. You can try same thing for the 2 bits. You will come to a conclusion that this formula is getting what? This 2 to the power of n minus 2 to the power of n to 2 to the power of n minus 1. You will get convinced with this formula. Okay. Any doubts? Making sense? Yes or no?
Yes, no doubts.
Okay. Now the next thing is, okay, now this is how you can calculate for each and every data type. Okay, what they are saying, let me write something. Please be informed that if you add to distinguish between, you have to distinguish between a negative number and a positive number, we will have to convert. What we have to do? We have to convert the number in the form of 2's complement. 2's complement and attach a negative sign to it. If you want to distinguish between negative number and positive number, you have to convert the binary number right? And also mem must be. You can do this only if the most significant bit, is 1. Making sense? Only if you find only if the most significant bit is 1, you can do this 2's complement convert. Actually, we don't have to do all this. These are the internal things. So what I'm saying is, if you raise power to something according to the number of bits, you will get only positive integer. Okay, how these things are happening? Why the negative numbers? How this conclusion has arrived? If there is no concept of negative numbers, okay, you can store only, if you ever had to store only the positive numbers in the byte data type, okay, you can store the combinations of how many numbers directly. You can substitute like this: 2 to the power of number of bits, okay, 2 to the power of 8. So what is the value? I think 256, huh? 256, right? You can store only 0 to 256. Okay, so in order to store the negative numbers also, they have introduced a concept called 2's complement. So they have considered the leftmost bit as the most significant bit. If it is found to be 1, okay, you do the 2's complement so that you will be in a position to store the negative values also. Making sense now? Okay, so let us keep this aside. We are going to do so. Everyone will treat this byte data type as a dummy data type, since the storage capacity is very less. Trust me, this is the most powerful data type. There are a lot of situations where you will be dominating the memory, because this is going to help you to save a lot of memory in the real-time applications. Okay, based upon this, we cannot say, okay, longest is of 8 bytes, so this is the greatest data type. Based upon the size, we cannot conclude. Memory, based upon the memory, we cannot conclude. Based upon the performance, we can conclude. Right? So the next thing is, we should to proceed further, we should also understand something like the bitwise operators. Okay, so we will come back to this once again, and I want you all to understand the concept of bitwise operators. Focus here. This is going to be very easy, guys. I don't know if you have seen these things in your graduations. Okay, now you will see its actual usage. Bitwise operators. In Java, there are many bitwise operators. The first one is bitwise OR operator. We have something like a lot of interview questions are there on top of these operators, bitwise OR. So symbolically, you can represent it like this is the symbol, special character to represent bitwise OR. And like that, you have bitwise AND operator, and you can represent it like ampersand operator. And you have something like a bitwise XOR and a cap symbol. Okay, and you have like bitwise complement operator, and this is the symbol for it. I'm not finding that symbol. This is the symbol. Okay, you have left shift operator. You have left shift. Okay, so two angular braces towards the left side, pointing towards the left side, and you have something like right shift. Or signed right shift. Two angular braces pointing towards the right side. Okay, and you have unsigned right shift. You will understand each and everything in detail. After this, we will come back to this primitive data type. So this understanding is important. Okay, So let us try to understand what is bitwise OR. Okay. To understand this, first of all, you all know what is a truth table, right? Truth table. So if I want to teach you about the truth table, okay. So let us take a table. So this table has three columns: A, B. This A, B, treat them like inputs, okay. And at last you are going to find what? A or B. Okay. What are the possible inputs for A and B? There will be four possible inputs. If you take only if you consider only two inputs, there can be four possible inputs. Okay. Either it can be, both can be 0, right? One can be 0, second one can be 1, according to the binary system I'm talking about. Okay, second one is 1, 1, 0, 1, 1, right? So what is the OR? Okay, when I say A or B, OR is just a line. Okay, just a line. When I say A or B, what does it really says? Hey man, don't worry much. If you find one as one of the inputs, so these are the two inputs. If you find one as one of the inputs, the combination of A or B should be 1. If not, 0. Able to follow? Very simple, no?
Yes.
Among two inputs, if one of the inputs is 1, okay, if you use OR operator, it should be 1. If not, 0. Having said this, let us try to understand a real-time interview question. Okay, so they have asked us like this. I don't know if you can answer this. I'm taking a class here. Okay, inside this class, I want to take public static void main string array box. Okay, and byte a equal to something like, I want to take it as let me take a small number only. Let me take 5. Okay. And again I want to take byte b equal to 9. You can answer this question. Let me see, or else we will try to understand this by going deep into it. Okay, I want to find A or B. A or anyone knows how to find? Yes, no? Don't know, or you know? Anyone?